Okay, so welcome to section 2.2, which is conversions. Conversions. Okay, so let's recall. When you divide a number by itself, you get 1. So when we divide a quantity by itself, we get 1. Okay, so for example, what do I mean by that? If I have, say, 1 pound divided by 1 pound, and it doesn't even need to be 1, it could be 15, but the units of pound reduce, and I'm left with 1, just the number 1. Another example would be, say, 5 miles divided by 5 miles. Once again, the units of miles reduce, as does the units 5 over 5. So anything divided by itself gives us just 1. Another would be, I don't know, let's do 6 dozen eggs, even though I'm allergic. Okay, so 6 dozen eggs. Once again, I can reduce the units of eggs, I can reduce the units of dozens, and I can reduce 6 divided by 6, because 6 divided by 6 is just 1. So any quantity divided by itself is just 1. So hopefully that makes sense. So now let's continue on with common unit conversions. Actually, let me do this in dark purple. So common unit conversions. Common unit conversions. Conversions. Okay, so let's first start with volume. So volume will be our first conversions, and hopefully everyone's familiar with these. So let's start with 1 cup. 1 cup is equivalent to 8 fluid ounces. If you cook, you might know that. 1 pint is actually 16 fluid ounces, or 16 ounces, which is actually how many cups? It's 2 cups, right? Because 8 goes into 16 twice. 1 gallon is how many cups? Well, that's 16 cups, which is how many pints? How many times does 2 go into 16? Well, that's going to be what? 8 pints. Okay, now what about a quart? 1 quart is 2 pints. And 2 pints is 4 cups, right? Because I know 1 pint is 2 cups. And last but not least, let's introduce some SI units. How about 1 liter? So 1 liter is 1,000 milliliters, milli being the prefix for 1,000. Okay, so now let's go to length as opposed to volume. So let's look at some length unit conversions. So 1 mile is how many feet? Well, it's 5,280 feet. 5,280. And 1 foot is how many inches? Well, 12 inches. Hopefully everyone knows that. And 1 yard is actually 3 feet, right? Similarly, 1 meter is going to be 100 centimeters. Centimeters, where of course cent again means 100. And 1 kilometer, km, is going to be 1,000 meters. Kilo is a prefix meaning 1,000. We'll get to those in a moment, hopefully. Okay, so now let's look at weight. We've done volume, we've done length. Now let's look at units of weight. Okay, so 1 pound is 16 ounces. And we're going to have to differentiate between fluid ounces and weight ounces, but I'll get to that in a moment. So 1 ton, T-O-N, not T-O-N-N-E, because that's a British measurement and it's different. So 1 ton in the US is 2,000 pounds. 1 kilogram is 1,000 grams, kilo being the prefix for 1,000, and that's equivalent to 2.2 pounds. Okay, so let's note this volume, fluid ounces. So let's note something that's very important about that. So the only time weight and volume are equivalent, so the only time weight and volume are equivalent is when measuring water. It's when measuring water. So everything else has a different weight and volume. Measuring water. So when we measure water, the volume is the same as its weight. Okay, so definition. Okay, so a conversion factor, that's what we're defining. A conversion factor. So underline it, that's what we're defining. So a conversion factor is a ratio equivalent to 1, like we started out this section with. So equivalent to 1. That is, i.e. id est, a ratio involving equivalent measures. So a ratio involving equivalent measures. Okay, so an example of that would be something like, well, 3 feet is 1 yard, right? So if I did 3 feet to 1 yard, this would be equivalent to 1 because they are the same. If I look up here for length, where was it? 1 yard is 3 feet. So these are equivalent. And remember, anything divided by itself is 1. So because 1 yard is the same as 3 feet, this is technically something divided by itself. So another example would be 2.2 pounds to 1 kilogram. Because 1 kilogram is equal to 2.2 pounds, this is also considered, quote, quote, 1. Okay, so these are conversion factors, and you'll see how we use these in the next example. So for example, so if you run a 6-minute mile, so if you run, that's a terrible Y. So if you run a 6-minute mile, So how many feet do you run? So how many feet? How many feet do you run in, let's do 18 minutes. Okay, so what do I want to find? So I want to find minutes. Or no, I don't. I want to find feet, sorry. How many feet do I run? So I want to find feet. Okay, so how many feet? That's what I want to find. Okay, so what I'm given is time, right? So I know that I'm running for 18 minutes, so I start there. So 18 minutes is what I'm given. And anything that doesn't have a ratio can be put over 1. And the reason I'm going to do this is because I'd like to cross-cancel minutes somehow. Well, if I look that I run a 6-minute mile, that means for every 6 minutes, I run 1 mile. Agreed? So what this allows me to do is to reduce the units of minutes. But I don't want miles, I'm still looking for feet. So let's see, maybe I'll use pink. So I'm still looking for feet. So in order to find feet, I need to cross-cancel miles. So I need a conversion factor that will allow me to reduce the unit of miles and have feet on top. So let's go back up here. And look, 1 mile is 5,280 feet. So what I can say is that in the numerator, 5,280 feet is equivalent to what's in the denominator, 1 mile. And what that allows me to do then is to reduce the units of miles, leaving me with simply the units of feet. So I have, well, let's see, 6 goes into 18 3 times. So what I end up with is 3 times the quantity, 5,280 feet, which is going to be, well, 3 times 5,000 would be 15,000. 3 times 200 would be 600. So 15,600. 3 times 80 is 280. So 15,600 plus 280 leaves me with 15,840. Sorry. 3 times 8 is 24. What am I saying? Feet. So this is how many feet I will run in 18 minutes. Okay, so that seems a little heady. But let's go back to something. I don't know if it's easier, but practice is always good. So if you had to carry a box, had to carry a box with 3 gallons of water, How many pounds would it weigh? How many pounds? Lbs would it weigh? Okay, so I want to find pounds, right? Lbs. Okay, so how many pounds? That's what I'm looking for. Okay. But what was I given? I was given 3 gallons of water. 3 gallons of water. And water is important here. So I'm given 3 gallons of water. And since it's not relating to anything, I'll just put it over 1. So how do I go from 3 gallons, which is a volume, to pounds, which is a weight? Well, let's see. Because it's water, what I can do is I can translate a gallon into, at the very least, cups. So 1 gallon is 16 cups. So my next conversion factor, in order to reduce the units of gallons, I'll put gallons on the bottom. So 1 gallon is the same as 16 cups. So now I can reduce the units of gallons. But I still want to find pounds. But I'm still on volume, not weight. So let's look at cups. So 1 cup is 8 fluid ounces, and there's an asterisk here. So 1 cup is 8 fluid ounces. So since I want to reduce cups, I'm going to put the cup on the bottom. So 1 cup is 8 fluid ounces. So now I can reduce the units of cups. I have ounces, but now I'm going to do something sneaky. I want to change from ounces to pounds. And even though I was up here, I'm going to use the fact that 1 pound is 16 ounces. And the only reason I can do that, the only time weight and volume are equivalent, is when we're measuring water. So that's the only reason I can change from volume to weight, because in this problem we're measuring water. So therefore I can say, okay, well, how many ounces are in a pound? Looks like there's 16 ounces for 1 pound. So since I want to reduce ounces, I'll put 16 ounces on the bottom and 1 pound on top. So now that's going to allow me to reduce the unit of ounces. And I don't need fluid here because I'm talking about water. And the weight of water and the volume of water is equivalent. Okay, so what am I left with when all is said and done? Looks like I'm left with 3 times 8. Well, actually, look at this. Looks like 16 reduces with 16, so I can get rid of that. And it looks like all that's left is the 3, the 8, and the 1 pound. So after all is said and done, 3 times 8 is 24 pounds. Okay, so there we are. That's how we do a conversion factor. So now let's deal with some geometry. So geometry, everyone's favorite, I hope. So similar triangles. So we'll first deal with similar triangles. Similar triangles. Have corresponding sides. So have corresponding sides. In the same ratio. So what does this mean? So let's look at similar triangles. So let's say I have a triangle here. Let's see, 1, 2, 3, 4, 5, 6. And then let's say I've got another one here. Something like so. Okay, so over here I have sides little a, little b, and little c. And over here I have sides large A, large B, and large C. So if triangle ABC is, I'm just going to say if these are similar triangles, then if I take the ratios of any two sides, say little a to little c, that's going to be the same as large A to large C. The bottom to hypotenuse, if these are right angles, are in the same ratio. Similarly, I could say maybe B over C on the little triangle is the same as capital B over capital C on the large triangle. Another ratio would be maybe, what don't I have, A over B on the small triangle is the same as large A over large B. As long as we're taking the ratio of corresponding sides, then that's how similar triangles are related. So the next subtopic to geometry is areas and perimeters. So areas and perimeters. Okay. So let's start with a rectangle. Hopefully that's the easiest. So let's, pardon me, have a rectangle. Let's go ahead and draw a rectangle with a length and a width. So this is the length and this is the width, not that it matters. Okay, so the area of this rectangle is going to be base times height, or length times width. So length times width. And let me actually write out the word area instead of just writing A. So we know what that is. So area is length times width, or L times W. But what about the perimeter? So the perimeter, if you walk a perimeter of something, you're going to walk all the way around the edges. So for us, if I put in this is W and this is L, I'd have a W plus an L plus a W plus an L if I walk the whole perimeter. So that's 2 W's and 2 L's. So 2 widths plus 2 lengths. So that's the perimeter of a rectangle. Okay, so now let's look at a circle and do the same thing. So a circle, we're going to look at the area and the perimeter. Let me go ahead and try and draw a nice circle if I can. It'll autocorrect. Okay, good enough. Okay, so a circle with a radius of R. Okay, so the area of a circle is going to be pi times radius squared, so pi r squared. The perimeter, which we call the circumference, so circumference, so this is actually perimeter for a circle. And that's going to be 2 pi times the radius. Okay. So I don't know if you've seen these before or not, but hopefully you have. If not, go ahead and learn them now. And now let's go ahead and apply them. So for example, so if you see a cat on the top, I don't know, shall we say top of a tree? So if you see a cat, you see a cat on the top of a tree. Top of a tree. And the base of the tree, is 15 feet from where you stand, so 15 feet from where you stand. And it's 6 feet tall. And at 6 feet tall, your shadow is 10 feet long. Shadow is 10 feet long. And we'll put in the opposite direction of the tree. Opposite direction of the tree. Of the tree. So how high is the kitty cat? So how high up is the cat? Okay, so what do we know? We are standing somewhere here. Oh, terrible stick figure. Let me see if I can draw it a bit better. So we're standing somewhere here. And let me make myself a bit taller. Okay, and I'm 6 feet tall. And what do I know? I know that the tree is 15 feet away. 15 feet. And I know that my shadow is 10 feet. So maybe there, 10 feet. What else do I know? So let's see. So my shadow is 10 feet. I know that the tree is 15 feet from where I stand. And I know that I am 6 feet tall. So this is 6 feet here. Okay, so my goal is to use similar triangles to find the height. So the height equals question mark. Okay, I want to find the height. So I can use similar triangles here because this is a right triangle where I stand. And this is a right triangle overall. So let's look at both of these triangles. So redrawing, I have the first triangle, 10 feet, whatever this may be. And I'm 6 feet tall, right? This is what the triangle looks like. So 6, 10, and a right angle. But then I have the next triangle, which is 10 and 15. So I know that 10 plus 15 is going to give me a length of 25. And I'm looking for this height here. Let's call it h. Okay, so using the fact that similar triangles are in proportion, I know that the height h divided by the base 25 is in the same proportion as the height 6 in the other triangle over the base 10. So all I would need to do to solve for the height h would be to cross multiply. So I can cross multiply the 25 over there. So multiply both sides by 25. And what that gives me is that the height h is going to be 6 divided by 10 times 25. Okay, so if you have 6 quarters, how much money do you have? Well, you've got $1.50, right? So that's 150 divided by 10. 150 divided by 10 is 15. So it turns out the height, h, is 15 feet. So that's how high up the kitty is. Okay. So let's do another one. See if maybe I can move this stuff up a bit. Let's see if I can make myself some more room here. I probably can, just a little bit. Okay, so let's do another example. Okay, so for example, so let's say a pizza parlor charges by the area of its pizzas. So a pizza parlor charges by the area of its pizzas. Charges by the area of its pizzas. So how much more does a 10-inch radius pizza cost? So how much more? And I'll get to that statement in a moment, that how much more does a 10-inch radius pizza cost than a 5-inch radius pizza? Radius pizza. Okay, so let's deal with this. How much more? Well, this is in relation. So how much more does the 10-inch pizza cost in relation to the 5-inch? So this is a relative change. So relative measurement. Okay, so the area, let's do the area of the 5-inch is going to be pi times 5 squared. So that's 25 pi. So that's going to be the 5-inch radius pizza. And let's do area of the 10-inch pizza. It's going to be pi times 10 squared, or 100 pi. So that's the 10-inch pizza. 10-inch radius pizza. Okay, so we know that the relative change will be the absolute value of final minus initial. But this is going to be, how do we find out which is the initial and which is the final? Well, whatever I put in the denominator, okay, why is that not moving? Okay. Whatever I put in the denominator is what I'm measuring against, and I'm measuring against the 5-inch radius pizza. So I need the area of the 5-inch radius pizza on the bottom. So 25 pi, because it's with respect to the 5-inch. So the 10-inch is 100 pi minus the 5-inch, 25 pi in terms of area. Okay, so I have the absolute value of 75 pi in the numerator, which is just 75 pi, divided by 25 pi in the denominator. So the units of pi reduce. And how many times does 25 go into 75? Or how many quarters make 75 cents? And that's going to be 3. So it's 3 times as expensive. So the 10-inch pizza is 3 times more costly than the 5-inch pizza. Okay, so one more example for good measure in this one. Let's do perimeter this time. So example, let's find the perimeter. Find the perimeter. in the following image. Or not in, of the following image. That sounds better. Of the following image. Of the following image. Okay, so what I'm going to have is, let's do a rectangle, or at least 3 parts of a rectangle. And then let's do something like a semicircle. I know that didn't really look good. Let me try and draw a circle and then just erase half of it. Okay, maybe that's better. I'll just erase this part of that. Maybe. Okay, so let's say that this is 6 feet just to get to where the circle starts. It's 3 feet high. And let's say that, what do I want? I don't know if that's going to work. Yeah, let's make it 4 feet high. I think that'll be better. So therefore, and this is going to be, this radius here, of course, is half of 4 feet, so that's 2 feet. Okay, so what is the perimeter here? So the perimeter is going to be, well, first I need to take the perimeter of, what color should I use? Let's use orange. The 3 sides of the rectangle. Well, this bottom is also 6 feet, so it's going to be 6 plus 4 plus 6 for the rectangle. But then the circumference here of this circle is only half. It's only 1/2 of the circumference of a circle, which is 2 pi times the radius, and the radius in this case is 2. So let me do that radius in blue. 2. Okay, so we have 6 plus 4 plus 6 is 16. Plus, well, what's nice is the 2, the 1/2 reduces with that. And I'm left with 2 times pi, and there we are. That is the perimeter of that object. 3 sides of a rectangle and 1/2 of the circumference of a circle. Okay, so hopefully this is making sense, and I will see you guys in the next section.